put onto the McDonald Miller YouTube channel. And if somebody wants to watch it at their leisure, that's an option. All right, so talking about refrigerant history, how we got here, talk about the phase out that we're going through now, some customer options. We'll jump into the future of refrigerants, so what we get to look forward to, and then what we're not talking about is flooded evaporator equipment. So for like Jeff Rosso and Morash, and if there's any other chiller guys, those big manufacturers have engineered solutions. Not saying they don't have options. That's not what we're discussing here. Now, if one of you guys wants to throw something out there about what you've done, if you've done any conversions on that flooded evaporator equipment, that's certainly cool. We're all about learning here, so whatever you got. But that's kind of the basis for this class. Before we get too far into this, has anybody done a retrofit on a like a package unit that's in this meeting here today?
Yes.
Yeah.
Yeah.
What'd you do?
I did 422. It wasn't D. I want to say it was B on a heat pump. A split heat pump, just a little guy.
Just a little guy. Okay. What? Okay, that's good at work. Great. What led up to that?
It was really just me wanting to try it. The customer didn't mention anything about it. It was just I wanted to try it.
Okay. And so that was a split system heat pump, and you said you put 422B in there, Bravo?
Yes.
Okay. And how long ago was that?
That was probably 3 years ago.
Okay, cool. Well, that's great. Thanks, Aaron, for that. Anybody else have a quick story on or done any retrofits from R22 to something else?
Yeah, Seth, I've done a 22 to 407C on some IntelliPacks probably 12, 15 years ago.
Oh.
It was a corporate driven. Their corporate was out of California for Mission Foods in Fife. And I wasn't real pleased. We lost a lot of efficiencies. Their equipment was right on the border as it was. So then they couldn't really hold the temps after we did the conversion.
Interesting. Did it start out kind of undersized or?
I think so. Yeah, I really do.
Okay. Well, that's good feedback. And that is a point of discussion in this today. There can be some efficiency or capacity loss. Efficiencies sometimes go up, but there can be some capacity loss, and we'll talk about that as we go in. I'm kind of blown away. About 15 years ago, that there was a corporate mandate for that, and you did a conversion. That's really forward thinking by that customer.
Yeah.
Yet,
well, the oil change wasn't.
Say that again.
Doing the oil change 3 times wasn't very fun either.
yeah, the running oil change. Yeah, we'll have a little bit of discussion around that as well. Cool. Well, thanks for sharing that. Yeah, so I mean, it kind of drives the point. We've been talking about this now for quite a while, and like Jared said, I mean, that was a while ago that he did that one. So this is, retrofits aren't a new thing. There's probably some of you on this call that back in the 90s, we went through the retrofits of getting rid of CFCs. We got rid of R12 and some of those older refrigerants. And then we moved into what we're doing now and getting rid of those HCFCs, those hydrochlorofluorocarbons. And we're moving into the HFCs, which have been around a long time. We've been using 410A and 134A, 407C for a long time. So these are refrigerants that have been around for a while. And so moving into them isn't a big deal, although they do have an expiration date. They're starting actually January 1st of 2022, the supply is going to be cut by 10%. And then over the next 15 years, we're going to see that dwindle. So we're going to be having this conversation again here, probably before you know it. And so the kind of the next phase is moving into the HFOs, the hydrofluoroolefins. And there are some equipment that are using these now out there. Jeff Morash, on the York chillers that you put in, are you seeing some of the HFO blends or some of the refrigerants that you might be on the bottom of the screen there?
Not with the York products yet, but the train, we did do the R1234Z.
Mm.
That was 1201 3rd Avenue with the two 800-ton train centrifugals.
Yeah, so these are out there now. Those HFO refrigerants. They're contained to. So there's HFOs and there's HFO blends, and I'll go through the difference here in a little bit. But the pure HFOs, they do have some flammability to them, and because of that, they're being confined to central plant type systems. So like what Jeff's talking about, we're not seeing them in rooftop units yet. We're not seeing them in split systems. We're not seeing them in VRFs, but they can be used where they're a central type system, like a chiller in its own mechanical room, and then water is being piped from it into the actual building. And eventually we're going to start seeing the HFOs more in our standard systems, although you can find them in your vehicles. I know that Chevy Silverado I got sitting out in the parking lot here has a HFO in it. I think it's a 1234 1234YF is what it is. So they are out there, and of course, if you go across the pond over to Europe and Japan, they're generally a little bit more progressive than we are, and they do have the building codes are a little more adapted to that type of refrigerant. So how we got here, we started talking about this a long time ago. The phase out, the last of the HCFCs were made by the main chemical manufacturers back in about January of 2019. They made their allotment, and that was it. And so we haven't had any what's considered virgin R22 since January of 2019. Now, of course, the supply was out there, and everything that we've had since and that you can go get now has been reclaimed. It's been put back in a service cylinder, sent back to a distillation plant. They clean it up back to new standards and send it out. At one time, they used to mark the cylinders, so you knew if you were buying virgin R22 or reclaimed, and that's gone away. It's pretty much all reclaimed anymore. No big deal. It still meets all the specifications, but our supply is dwindling. When last time we did this presentation, was it, I don't know, a week and a half or so ago, R22 was $2,000 a cylinder. Now it's come down a little bit. I called RSD this morning and it was 1,300 and some change. So it has come back down as the demand went down towards the tail end of summer. But that's why we're talking about it, because what we don't want to do is forget about it, have the price come down, have the supply come back up through the winter, and then come spring, we start using 22 again, like there's no issue. We want it to be on our minds. We want to be thinking about the opportunities to get those customers off of our 22 and onto something that's a little bit more sustainable, because I can guarantee that next year the price is going to go right back up where it was, probably more. And we're limited to one cylinder per vendor for a few weeks, just a month ago, not even a month ago. And that's probably going to start sooner next year. Instead of being an issue in September, October, maybe it starts in June. I don't know, but they're not making any more of it. So that's what we're going to see. We're going to see more and more shortages. So this needs to be top of mind. It needs to be something that we talk about and we're familiar with. So when you talk about retrofit conversions in general, there's kind of three options for customers that have R22 equipment or any refrigerant that's facing a phase out or phase down. They can do nothing. They can take that refrigerant out and they can replace it with an HFC or potentially an HFO blend. We'll talk about that. Or they can replace the equipment. And we're going to go through kind of the pros and cons of those. The kind of the do nothing approach, bury your head in the sand. Of course, there's always a silver lining, and that's that if the equipment was designed to want to run on 22 or whatever it's shipped with, it's going to run the best on it. That's what it was designed for. That's what's going to be the best for it. So there is an argument for that. R22 equipment was sold up until 2009, maybe even very beginning of 2020 or 2010. So it's possible it's only 11 years old and there's still some life left. And in that case, there might be a business case for keeping it around. They can use time to budget for a unit replacement. So rather than spending the money on a retrofit, maybe they can save the time and effort and just replace the unit. And it's important to note that 22 isn't banned from use. There were several instances leading up to in the last couple of years. There was contractors that were telling customers that R22 was going to be banned and they had to get rid of it. And that's certainly not the case. It's just a supply and demand issue, and customers are better off if they address it and take action so they're not caught in a pinch if and when they need some refrigerant. They need to keep their equipment running. The downside, R22 right now is right about $50 a pound, and that's our cost. I mean, that's what we're paying off the shelf. So it adds up very quick, and that's if you can get it. It may be that we can't get it, so we have to do something else. From a property manager or building owner perspective, when you talk to accountants, they see that as a liability. If you're CBRE or Jones Lang LaSalle or whatever your favorite property manager company is, if you have a bunch of systems on your buildings and they all hold 15 pounds of R22, times that by the number of buildings or systems, and that's a lot of money sitting up there, and so that becomes a liability. It's an asset at that point, and it's potentially a lost asset. So that's something that the bigger property managers look at and they think about with these systems. So there's definitely a business case for getting rid of that refrigerant, doing something else with it. Generally, if there is an unexpected blowout, you got a fan comes loose and goes through the condenser coil, or somebody shoots it with a 22, or depending on where you live. If that system has to run today, there's a good chance that you're going to be pumping R22 back into that thing to get it running, just because it's easy. And so with a little bit of training, a little bit of education, there are options. And that's this is kind of the beginnings of that. And then of course the suppliers are limiting. When I called RSD this morning, they had 5 jugs sitting there on the floor. And Mel over there said that depending on the customer, they'd be willing to part with all 5. So there is a little bit of flexibility that's starting to come back in the market. But during the height of the summer and the tail end, it was 1. So kind of depends on the market. Whoa, what the hell happened there? Completely lost the deck there. Hang on, we'll get back there. So with a retrofit, the good part is if you plan it and you execute it correctly, then it's going to save them some money. It's going to kind of hedge their bets, protect them against the future. They're not going to have to worry about the shortages. A lot of equipment built in the mid to 2000s could have shipped with 22 or 407, and so it was already designed for it. And because of that capacity loss, efficiency loss, they're going to be negligible, and you're not going to have many problems. So that's kind of an important part when talking to customers. Also, R22 has been known for a long time as a compressor killer. It's got high discharge temperatures, breaks down the oil. The replacement refrigerants, they generally have a lower discharge temperature. So there might be a case there for saying the compressor might last longer. There is some instances where we can sell the R22 back. At one time, they were offering $10 a pound through Hudson. I'm not sure where it's at right now, but there could be a case for that if a customer has 200 pounds of R22, or maybe in the case of like SeaTac Airport where they got thousands of pounds, there might be a business case to sell that and offset some of the cost. Now, of course, they have chillers, so it's not going to be under scope of this training, but once again, there could be a case there. And then on larger multi-circuited units, we've done several IntelliPacks where we've done one circuit, and then so the customer can get kind of used to it. They can see that it's going to work, and then as it proves that it does work and there's not a failure or anything they have to worry about, then we can do the other circuits. So it is possible to do individual circuits over time to kind of get that buy-in. Kind of the cons, there, as Jared mentioned, there can be a drop in unit capacity. Now, generally, in our experience, we've only seen that on design days, and or at least here on the western side of the mountains, we're not at design days very often. Generally, these are designed for about 100, 105 degrees condensing, and we're not at those temperatures that often. At least historically, we haven't been. So until you're at those design day temperatures, you don't see that capacity drop. Now on the east side of the mountains, that could be a different story. I'll show you some trends or some I don't know what the word is, but we did some testing through our tab department where we read before and after, and I'll show you those results here in a minute. There could be a decrease in energy efficiency. That would come down from potentially longer compressor run times, but it could be offset by a compression ratio and lower amp draw as well. So I think the capacity and the efficiency is really negligible in our experience so far. Depending on the type of unit, oil return could be an issue. That's more to do with split systems. Specifically, if you have a compressor sitting up on top of a roof and you have the evaporator down below, there's a few considerations that we have to take into account to make sure that we get that oil back. And it's generally going to be the addition of POE, synthetic oil. Of course, warranties will be avoided. Most of the time, that's not going to be an issue because all this equipment's over 10 years old as it is. And depending on the what it is that you're converting, part availability may be an issue. I was talking to one of the techs down here in Kent earlier today, and he's got some old Boeing buildings up in Renton where the liquid line solenoid valves are they're starting to leak, and he's tried rebuilding them, but they're not taking the rebuild, and so they have to order new liquid line solenoid valves when they do retrofits. And so once again, depending on what you have to do for the conversion, some planning might need to take place rather than just thinking that the parts are in stock. So once again, good planning goes a long ways. And then lastly, unit replacement. We all know that replacing a system is generally good. The downside is that the current units that we're getting have an HFC in them, and that is planned for phase down. So it's kind of like buying a computer, where by the time you get out to your car, it's already outdated. That's kind of where we're at with these systems. They're still in compliance. They're still being sold. They're still generally more efficient than what you have now, but they're on a schedule for phase down. So that's kind of about the only downside. In supermarkets, they've already banned HFCs in Washington. So what are we doing? We have two standard replacements that we, as McDonnell Miller, have made available and that we talk about the most. Doesn't mean that we can't or won't use other refrigerants, but this is our standard, and that's what we'll go through. So our 422D, we kind of consider that a smaller tonnage type refrigerant, and that's where the oil is not being replaced. 422D, it moves mineral oil. It'll also move POE oil. We kind of consider it a short-term option for larger equipment. So you could, if you came up to an IntelliPack or a Mammoth that had mineral oil in it and it had lost a charge, you can put 422D in it. You can leave the mineral oil and it'll run. We prefer to go with 407C on the bigger equipment. And the reason is that's the way that the manufacturers went, and we want to be consistent. We also see that the efficiency gains and the capacity gains are better with 407C. They're closer to factory, where 422D tends to, we have seen more of a drop in that capacity, but it's been negligible. So kind of the guideline there is if you roll up on a 5-ton train Voyager and it's blown its charge for some reason and you're able to fix the leak, 422D is a really good option for that. You can leave the mineral oil in there. You can gas it back up. You should always replace the dryer. I mean, that's good practice anyways, is replacing the liquid line dryer. But your standard work kind of workflow there would be fix your leak, pressure test, pull a good vacuum, and charge it back up. So pretty straightforward. And then replace Schrader cores and caps. Now, most of your 5-ton equipment doesn't have other rubber containing equipment, but we'll go through kind of what that means and items to look for. As far as 407C, this is a great option on the bigger equipment where you're going to replace the oil, or if you have a compressor failure. So say like that same 5-ton Train Voyager, if that had a compressor failure. Now, of course, as we all know, most of your oil is contained in the compressor. And if you're going to replace that anyways, that's a great time to do that conversion to 407C. Anymore, when you order a compressor, it's going to either show up dry or it's going to have POE in it. So there's no use dumping the POE out just to put mineral in. So you might as well just do the conversion at that point. Put the compressor in there. It's already got the POE. Place the dryer, pull a vacuum, put in 407C, and away you go. So pretty straightforward on that smaller equipment. We'll go through the other components here in a minute that you're going to want to take a look at and replace or rebuild. And the reason that we chose these refrigerants is that they're both Honeywell. They're actually more generic than that. You can get them from DuPont or Chemforce, but you can get them at any parts house for the most part. So we're not saddling the customer with some type of refrigerant that you can only get out of one place, like in California or some kind of boutique type refrigerant that isn't easy to come by. So on the 422D, currently it's running at about $11 a pound. So about 20% of R22. So big difference there. No oil change needed, so it'll push mineral. It'll move POE around as well. So it's really close to R22 in that it'll move both types of oil. Good option for smaller tonnage. Great option for like an emergency. Got to get something back up and running. You don't have time to change components or change the oil. You can gas it up and go. So it makes it pretty easy for that. It's important to note there is no manufacturer limitation on the tonnage. We generally talk about kind of 10 ton as our break point where we'd like to see 407C go in, but there is no like hard and fast rule on that. It's just that's kind of when we came up with these guidelines, that's where we went with it. And then 407C, it's a little bit more money, $13 a pound. And I think that's going to come down. It kind of depends on the tariffs. Right now, there's tariffs on refrigerant coming from China, and so it's driving the price up. Here about a year ago, this was closer to the $6 a pound mark. It was quite a bit less. We've seen the jump because of the tariffs. So there's a good possibility that it's going to go down. It's good for any unit that you're replacing a compressor. So you're already taking the bulk of that oil out. So it's a good time to put POE in, or if the compressor already has POE, you're already there. If you are doing an oil change, we want to see 80% of that oil being POE. Honeywell in their literature does say that 20% is acceptable. So you could actually have 80% of that residual mineral oil in the system, and you could have 20% of POE on top of it. But one of the issues with that is these HFC refrigerants, they don't bring the oil back. They don't bring mineral oil back. It doesn't get entrained in there. And so the compressor will still pump that oil out, but it's going to get logged somewhere. It's either going to sit somewhere in a condenser or the evaporator, probably the evaporator because it's colder, and it's going to take up space. So now those bottom rows of your evaporator coil are doing nothing. They're just oil logged. And so that's where some of your capacity loss can come from. If you don't get all the mineral out, you end up with just basically blocked bottom rows of your coil. So something one of the real kind of considerations is to get that mineral oil out of there. So what's McDonald Miller doing here? We actually converted the lower building here in Seattle back in 2017. There's a mix of probably 4-ton to about 7-ton package units up there. I think there's probably about 10 of them, something like that. And we converted those to 422D right before summer of 2017. And they've been running just fine. They've ran every summer since. They ran through the heat dome we had earlier this year. We haven't had any compressor failures. We haven't had any issues at all. So it's been a really good test case for this 422D. And like I said, we didn't change the oil. We just did the basic, pull the 22 out, replace the dryer, pull a vacuum, and put in the 422D and replace the cores and caps. So super easy, been running just fine. We've done a fair amount of Liebert conversions to 407C from 22. We've done a lot of IntelliPacks, especially on the east side of the mountains over at VMware. There's been a bunch of them. We've done a bunch on this side. We've done quite a few Mammoths, the T-Mobile buildings, and then several downtown Seattle. We've done the water source Mammoth units, and we haven't had any issues with those. And we haven't had any noted efficiency or capacity loss on these retrofits. And here's kind of an example. This was a data center that we did. I think these were data air units, but I'm not 100% sure. Maybe somebody recognizes the name. But you can see on the left we have R22 unit, and kind of at the bottom you can see our total BTUs an hour. So we were absorbing 303,000 BTUs per hour. And on the unit next to it, we converted to 407C and then ran the same test. So these were identical units, same model number, sit next to each other, same runtime, same age, all that good stuff. And you can actually see how there was a little bit of a capacity increase on this to 324,000. And that's pretty common. And the reason is that somebody is actually taking the charge out and then weighing it back in and trimming it. Whereas a lot of times you get systems that are maybe running slightly low on charge. So they're not running at full capacity. And now all of a sudden you've pulled the charge out and maybe even made other repairs at the same time. So maybe cleaning coils or maybe even replacing coils. And so now you got a system that's back up into running in proper operation. So that's, in this case, that's where that came from, was a proper tuning, proper charge. But it's important to know we didn't have a drop in the BTUs, which is important. All right, before I move on to kind of how we quote these things, do we have any questions out there? Nothing? I hear a kid.
Sorry, I'm with my kid, sorry. I got a question. So basically, if you're swapping it out with, let's say, a 407C, so I don't know if you covered this or not, but TXVs still stay the same, or you're swapping out TXV as well?
No, you generally don't have to swap out the TXV.
And that's with 422 and 407?
That's correct. Yep.
Okay.
Yeah, with a thermal expansion valve, we haven't seen adjustments by using 422D or 407. If you have a fixed metering device like a cap tube, there's more considerations. But to my knowledge, we haven't done any critical charge type of equipment with a cap tube.
Okay, sounds good.
Yeah, it's not to say that there couldn't be an adjustment. It's certainly possible. If you and I think it probably be good procedure if you do a conversion as you're checking your superheat and your subcool. There could certainly be some adjustment there, but we haven't seen it's instances where we had to do a TXV replacement because of it.
Hey, Seth.
Yeah, Aaron.
I saw a couple bottles of new 22. on the shop shelf. Any info about that?
Did those just show up?
They've been there for like 2 weeks. They're like dark blue.
I don't know why they're there. I will tell you that if you're on a customer site and they've already done some conversions, we want to stay consistent. And so we have done other refrigerant retrofits. We've done some new 22, we've done some 421A, 427A. But those were because that's what the customer had started with, and we wanted to be consistent. The last thing you want is to have a bunch of different refrigerants on a roof. So it's possible that that's where those came from, but that's not our standard refrigerant.
Got it.
And I don't have any other information on what anything about new 22. All right, easy peasy. So as far as quoting a retrofit, say you go out to a site and it's one that you're not going to swap it out right there. If that is the case, that you want to swap it out, if you want guidance, you can always call me. You can call your foreman or your AOM or probably Jeff Morash. He's a knowledgeable fellow. If you want to quote it, we have a process for that in the Mac Service app. So when you go into Okta and then Mac Service, I kind of put over on the left-hand side where it's at. So it's kind of between plumbing service and replacement compressor startup. There's a form there, and these are the questions that it asks you. So these are questions to keep in mind if you are going to do a conversion, whether it's on your own or you want to have it quoted. How many circuits are we talking about? What's the current refrigerant? How much oil is in there? What type of oil is in there? How much refrigerant per circuit? Is it fully charged? So kind of get an idea, like, is it gonna, like, for future, is it gonna run better, or is there a leak, or just kind of capturing, like, what current state is the system in? Are there oil drains on the compressor? Because that can come in if you're gonna go from mineral to POE. Got to come up with a way to get the oil out if you're not swapping out the compressor. How many dryers, what size, what type? Are they core? Are they sweat, flare, stuff like that? Number of Schrader cores. And then, of course, what size? Is there any components that contain rubber or an elastomer? We'll want to capture that information so we can replace them. And I'll go through some examples here in a minute. And then, are the TXVs adjustable? That's mainly a question so that we know, do we have wiggle room? And if they're not adjustable, one of the questions that I would ask, or like Link, I think Link might be on here. Link's quoted some retrofits. If we're at that limit of capacity where maybe the equipment's already close to being undersized, having an adjustable expansion valve could give you the wiggle room to get through that if there is an issue. And if they're not adjustable and we already know the equipment's undersized, maybe it is something we look at is going to the next size TXV. So it's just kind of having that additional information is important. For kind of, I think it's a good practice too, is go take a look at the expansion valve, especially on the bigger equipment. You'll see on a lot of those, they're stamped R22 and 407C. And that's because those two refrigerants have very similar mass flow rates per ton. And so it kind of gives you that extra reassurance if the customer or if you are nervous about the possibility of a conversion or how it's going to handle. And look at the nameplate too. On the IntelliPacks, you'll see where there's a column, and then they check the box what refrigerant that's shipped with. So it kind of gives you and a customer that reassurance that this is a factory replacement if you're going to 407C, and that the equipment was designed for it. So it's kind of one of those nice to know pieces. And then we get into talking about elastomers. So what elastomers are rubber, rubbers are elastomers. And most of you have probably heard that when you do a conversion that you're going to have leaks, and it's true. You will have some leaks. Could be refrigerant, could be oil, could be a mix of refrigerant and oil. And part of that is due to POE oil being a lower viscosity. potentially. And if you've ever done a synthetic oil change on your vehicle, especially an older one, they generally leak. They leak by the seals. I did one on my Jeep, God, probably 6-7 years ago. I put synthetic in it, and it seemed to just run right out the bottom. It was pretty impressive how fast the oil leaked out of that. And I put mineral back into it. Brendan's having connection issues. And so POE oil has a easier time finding leaks. And so a lot of times it gets associated that's the POE oil that is causing the leak. And it's not true. The leaks are caused by the chlorine that's inside of the 22. So HCFC hydrochloro, it's that first C. And when you take out that HCFC refrigerant, you're removing the chlorine. Well, chlorine gets into elastomers, it gets into the rubbers, and it makes them swell slightly. And so when you take that chlorine out, as that chlorine off gas is out of the rubbers, they shrink back to the normal size. And that's where the leaks come from, is those rubbers have been sitting at a certain size, slightly larger than they were originally. Now they're shrinking back to the normal size, and that's where the leaks can come from. So it's important that we either replace them or we tighten them when we do these retrofits, when we go to an HFC. Replacing a lot of times is easier, especially when you get into like Schrader cores and caps, but tightening can work too. Think about like motor terminals, caps on devices. So there is the possibility, and it's recommended. Think about like a Train Model R, or you get some of these semi-hermetics like a Copeland 06D or something, where those terminal plates can be quite expensive. And if you can get in there and tighten those terminals up, you can avoid replacing or rebuilding that terminal plate. So it's a good option to talk with the customer about. If you've had issues with terminal plate gaskets and they're the studs, the stud gaskets or the seals in the past, then it's definitely a conversation you're going to want to have, and take a look at those before you do the conversion to see, can you tighten them from the outside of the motor or the compressor? Can you tighten them without twisting the stud? Like kind of what your options are there. It's also important to note that seals like Teflon, so like Rotolocks, Rotolock seals aren't affected. Metal gaskets aren't affected. Paper gaskets aren't affected. So any of those types are going to be fine. It's just the rubber seals. Those are the only places that we have the issue. Because if you don't do anything with those, you're going to have some leaks eventually. It may not be right away. It might take a year to develop, might be less. It's hard to say, but there will be some leaks. So we want to take those into account before we walk away. So some examples of where the elastomers are: Schrader cores, Schrader caps. You could say you just tighten them. Of course, they're cheap and easy. Might as well replace the things. Things like EPRs, heat reclaim valves, and liquid line solenoid valves. Those all have rubber O-rings in them. And the way that these are built, you can't just tighten the nuts on the top. You have to replace the O-rings. And if you, in your experience, if you have like an older ASCO valve and you've tried rebuilding them in the past and they leak or they don't work properly, it's probably best to just consider cutting these out and replacing them rather than trying to rebuild them. But it might be worth a shot. If it's a newer valve, then ordering that rebuild kit, not having to cut into the system and braze, it's a good option. And then also things like ball valves. Some of these have Teflon seals in them. Some of them have O-rings. So just tightening those down will take care of the problem, but it's important to actually tighten them down. 3D scrolls have a few special needs, we'll say. Because of the way that they move the oil, older 3D scrolls don't take well to POE. So it's important to make sure that the model numbers match up with those ones at the bottom. So down you can see CSHA and CSHC. The model number has to start with that on your train 3D scrolls if we're going to do a conversion. If they don't start with that, it means that they're older, and the older oil pump, it's a slinger in there, it doesn't move the oil properly, and we're going to have lubrication issues. So we have to make sure that the model number matches. We also want to make sure that there's a crankcase heater on them and that the crankcase heater works. So probably a good idea to replace it. We want to get a check valve in the common discharge line. These had a tendency for the check valves to fail in them. And what can happen is in the off cycle, the refrigerant will come back. And if the crankcase heater's good, that's fine. But if it fails, it'll get underneath the oil just like any system. But these have a really real hard time lubricating themselves. If you get a mix of HFC in there, the HFC tends to cling to the POE more, and the oil pumps in these scrolls have a hard time kicking that out. So they have some lubrication issues. So it's important to get that crankcase heater in there and get a check valve in the common discharge line for that, prevent that off-cycle migration. So here's kind of your procedure. You've traveled down the road of, you've identified a system that needs a retrofit, customers on board, you've agreed that it'd be a good time to do it. So it kind of starts with get some baseline data. We have tasking built for this in Mobile Tech. So if you ask your friendly coordinator for refrigerant tasking, they'll be happy to send it over, and it asks you the specific questions on that we'd like to see for that baseline data and the post conversion data as well. But we want to know, how's that unit operating now? Because if it's not operating properly with 22, it's probably not going to operate properly on anything else. So we want to try to capture that data so we have something to compare against in the future. So you pull the gas out, weigh it, record it, take the oil out and record it if you're doing a 407C conversion. So we want to know how much oil you took out, so you know how much to put back in. We're going to put the same amount of POE back in as the mineral oil that you removed. Once again, providing you're doing a 407C conversion. If there is an elevation difference, so say a heat pump or a split system, we're going to put in 1 ounce of POE for every 4 feet of elevation difference, and we're going to do 4 ounces a minimum. So that's if you're going to stick with mineral and you're going to put 422D in there, then we're going to add some POE on top of it. And that's just been found out through testing, through Honeywell's testing, that even though 422D will move that oil, it'll move the mineral. When you have an elevation difference, it helps to have a little bit of POE in there. So that's our guideline, is to add some POE in there if we're doing split systems. Replace the dryer, replace the rubbers, pressure test, evacuate, so all the normal stuff. You're going to weigh in 90 to 95% of the charge of the new refrigerant, and that's going to be for either refrigerants or any refrigerants. And then we'll top it off based on superheat and subcool. So we'll trim it. And then we want to make sure we get a sticker on there that shows what the refrigerant is that we put in there. And it also contains like what the oil is, how much oil, the date of conversion, stuff like that. We have stickers. They should be in every office. They're for the refrigerant type. So there's 407C stickers for 407. There's 422D for 422D. We have them for the other refrigerants too. We have some 427s. We have some, what's the other ones? Anyway, we have about 6 different ones just for those customers that have already started a conversion, and we're going to continue it. So you can talk to your foreman or talk to me or talk to your AOM, and we'll get you the sticker you need. Somebody mentioned running oil flush. Now, like a lot of things, when a process first comes out, we tend to err on the side of caution. And when conversions first came out, that was the manufacturer recommendation, was to always do a running conversion. And that means keep the 22 in there and then change the oil while you leave the 22 in. So get as much of the mineral out, put in the POE, because 22 moves POE just fine, and then let it run for a period of time, say 24, 48 hours, maybe longer. and then drain the oil out again, put in POE, and then kind of rinse and repeat. And generally 3 was the guideline. There is an oil refractometer available. I think it's from Supco that will tell you how much mineral versus POE you have in your system. And so you can use that. Now you don't have to do this on every system. And in our testing and the ones we've done, very few have we actually done the 3 oil changes. But there are customers out there that want that. They've read that it's part of the procedure and they're willing to pay for it because it is expensive. You got to think, kind of like Jared mentioned, like doing those through oil changes. You're coming back multiple times and you're taking the oil out and swapping it, and it adds dramatically to the cost of a retrofit. And in our experience, it hasn't been necessary, but it could be something that you end up doing. So it's important. It was important for me to at least talk about it and bring it up so that you guys were familiar with what that term is and kind of how it works. As far as the charge goes, there's going to be a difference in the amount of charge that you put in versus what you took out, providing that what was in there was a full charge. You're going to see about a 4 to 5% less charge on the alternative refrigerants. And there is a calculation. For the smaller tonnage stuff, I can't imagine that you're going to go through this process. But if you're quoting a huge amount, it's probably going to be worth it. So if you were doing 1,000 pounds of refrigerant, you can see there's a chart there for it. So in this case, like for 1,000 pound swap over from 22 to 422D, you're only going to put 959 pounds back in. So that's 40 pounds that you wouldn't have to buy. For most of what we're doing, I can't imagine you would do this, but I thought it was important to at least tell you there is a formula, there is a way to calculate it if you wanted to. But the kind of the moral there, the takeaway is that you're probably going to put slightly less refrigerant in than what you took out. So once you do that, that's where the that's where the charge comes in. That's where the superheat and subcool. I don't think glide is anything new to most of you. We've been messing with our 400 series refrigerants for quite a while now that are multi-part. And so you end up with this difference between superheat and subcool, or bubble and dew. Kind of the way that I remember it, if it's new to you, there's 2 charts there. There's a bubble column and a dew column. So you use dew for dew for superheat, and bubble for subcooling. Kind of makes it a little bit easier. 407C has a decent glide of 9 to 13 degrees, and 422D is a little bit tighter at 7 to 8. And so as you charge that, as you take your readings, you'll have to refer to the applicable chart and then make sure that you're reading it properly. As far as head pressure controls go, if you have a head pressure control that's operating off of condensing temperature, you'll look at the 2 columns, the bubble and dew, and pick a number between them. So let's say you had 407C. Get my mouse over here. If you had 407C and a condensing, say you're running at 100 degrees condensing, that's where you wanted to set your head pressure control. So if you look here, your bubble's 225 and your dew is 196. So you'd pick somewhere in between there, and that's where you'd set your head pressure control. So probably 200 or 210, probably 210, somewhere right in there is where you'd set it. And that way you're maintaining your head pressure properly. A little bit extra info. I kind of mentioned that already. If you've done some conversions or the customer's already done some of a different refrigerant, it's important to stay consistent. We're not pushing either of these refrigerants on them if they don't want it. We'll certainly sell them anything they want. We're in the yes business. We just want to be mindful of, if they haven't chosen already, we want to be consistent. We don't want to end up with a bunch of different types on our roof. Makes it a little bit confusing for everybody. And then we have a database that we've started. So if you guys do any retrofits, if you can send me some details, I'll document those, and it can help speed up processes in the future. We've done that with mammoths. There were several mammoths that we've done downtown. Yeah, that it comes in handy to know what we did in the past so we can do it again, have that recipe for success. Same thing with IntelliPacks. So just kind of let me know if you, same thing too, if you had an issue, it'd be nice to know and capture that and figure out how we can prevent it in the future. So try to get that out. Kind of wrapping up on this, we're not looking to convert every piece of equipment. McDonnell Miller's always been really good about making recommendations to customers that are valid. And so we're not in the business of scaring anybody. But we want them to be educated. We want them to know their options. In most cases, a lot of the equipment's going to stay as 22. If it's running good, there's no use messing with it. But we want customers to at least know their options. And if you do come up on those systems that have blown a charge or having another issue, I want you to have the knowledge and the training and the confidence to make a recommendation and explain it to a customer. So kind of what's next for you guys and the zone offices. Traditionally, we stock 10 cylinders each of 22, 407C, 134A, 410A. We've cut the R22 stock at the offices to 5, and we've filled those 5 empty slots with 422D. So this is a picture of the Tacoma office here, the Kent Tacoma office, or no, Kent service office. You can see the 22 on the left, and then those green cylinders are the 422D. The intent is to make it more accessible. So if you do run into an opportunity where you can do a conversion, they're here, they're ready. If you want to grab a jug and throw it in your truck, that's cool. If not, just know where it's at. For you guys that are on the outlying areas like Jared, if you want to keep some in the shop or wherever you want to keep it, I think it's a good idea. So at least it's ready and accessible. And as far as the phase down for HFCs, this was off of the EPA website. This is kind of where we're going in the next few years. So starting with January 1st, we're going to see a 10% reduction in the production of HFCs. I doubt we're going to see much of a bump in price because of that, but there is going to be a reduction. And then we'll follow that up in a couple years. That's a pretty good jump there, going to 40%, and then 70, then 80, then 85. So we're gonna be seeing this again here in about 10 years. We'll probably be feeling the pinch on the HFCs, and then talking about more of what the alternatives are. Currently, here's a couple of options. So I'd mentioned in the beginning HFOs. Jeff mentioned that Trane units have some HFO options that we've installed. We have HFO blends out there now. And I think actually a job that Jared's involved with over in Spokane, they're going to quote, not one of these, but they're going to quote an HFO blend as a replacement. They're going to actually skip the HFC they're going to go from R22 straight to a HFO blend is what it sounds like. So that's kind of a cool option. I don't know if we've done others. I think there might have been one, but I don't have the details. And the reason that they're doing the blend is, as I mentioned earlier, the true HFOs are somewhat flammable. And because of that, our systems and our building codes aren't ready for that in the package units and the split systems. So by doing a blend, it removes the flammability from it. And if you're not aware, R410A, half of that is R32. And R32 is a flammable refrigerant on its own. But blended with its counterpart, it's not flammable. So this isn't anything new. It's just a different chemical composition. So we're going to start seeing some of these blends. You can see this one's actually designed as a replacement for 410A. So that is something that's out there now. The one on the right, that's a replacement for 134A. There's also a replacement for 22 in medium and low temperature. I haven't seen a replacement HFO blend for high temperature yet. So like our comfort cooling, I haven't seen that one yet. The HFOs, hydrofluoroolefin, they are a class A2L. I'll show you what that means here in just a second. HFOs are in vehicles now. So like I mentioned earlier, that Chevy out there, it's got an HFO in it for automotive. So that's the that's the future for sure. And then as Jeff mentioned, we have some out in chillers that are going in. So where that flammability comes from, and you hear that term A2L, this is the chart that gets referenced. So this is a flammability and a toxicity chart. So like down here, you have A's and B's. So A is non-toxic, B is toxic. And then as we go up, we get into higher flammability. So like R22, 134A, those are A1s. They're non-toxic and they're non-flammable. Ammonia would be a B type refrigerant. It's toxic. What we're looking at with these HFOs and like R32, those are class A2L. So they're non-toxic, but they're not quite a 2 on the flammability schedule. So they came up with this L, which means light. So it's a L2 light or 2L light. And what it means is if you were to take one of these cylinders, stand it up so it's vapor and crack the cylinder, if you held a lighter up to it, it would light. It'll shoot flame out. But if you take the lighter away, it goes out. So they're self-extinguishing. They're not like a higher flammability refrigerant that continues to burn. For reference, propane, R290, or butane, R600, those are both class A3s. So that's as flammable as it gets. So they're not super flammable, but there's some potential there. And that's why we can't just take out a non-flammable refrigerant, put in even a mildly flammable refrigerant. They're not built for it. They don't have the components for it. And if any of you have, like, especially on the south end working at Kaiser, formerly Group Health, there's a ton of the little reach ends and freezers that run on propane on the R290 or the 600. As you probably know, the components are all built for that. So they're all sealed. All the contactors, relays, motors, everything's enclosed so that there's no chance of a spark and ignition. And even though these refrigerants are lower on the scale, there's still going to be some consideration there so that we don't have any explosion issues. All right. Well, that's all I got. You guys have any questions or anything you guys want to talk about refrigerant conversions? Gotta be something. Shane, you got any questions? No?
You did too well, Seth. No
Did
question.
too well. Answered them all without you asking. Well, if you guys don't have anything, 5:03, we busted through this thing pretty quick. Oh, Shane likes the Tom Petty. You want me to do that as an outro? We'll take her home with Tom Petty.
Everybody loves Tom Petty.
Everybody loves Tom Petty. Yeah, you're right. It's a shame. All right. Well, like I said, that's all I got. So,
Hey,
what's
Seth,
up?
at the last second, could I ask, do we have any experience converting heat pumps yet?
Well, yeah, so Aaron Berge chimed in the very beginning. He had done a heat pump. So, yes, I know of at least one other on the south end that got done. But we don't have a lot of experience with it, no.
Okay.
When you look at the manufacturer's literature for 407 and for 422D, they both specifically say that heat pumps will run just fine.
Oh, all right.
But I have not seen.
Okay, thank
But
you. That was my only question.
I think it would be fun to find a test unit though.
Absolutely.
And see what happens. Yeah, I wonder if this is a heat pump here in Kent. Maybe I'll look into that and we'll see if we can swap that over. and get some data on it.
Yeah, I'd particularly be interested how the defrost does.
Yeah. Well, you know, one
Okay.
of the questions that has come up before about heat pumps is well, if we have a lower discharge temperature. Oh, hang on, music started. Who the hell's my mute?
Yeah, I know they're using
I'll turn it down.
latent state of condensation
But
to do
yeah,
that.
the argument
latent
sometimes, or at least the question will come up is, if we have a lower discharge temp from these, how are we getting the heat out of the heat pump? And it's not a bad question. That our heat comes from that. It's the latent heat. It's the phase change from going from a hot gas out of the compressor condensing into a liquid. That's where that heat's coming from. It's not so much that the discharge temperature is hot, and we still go through that phase change. So still get
I get the math,
still like
but
to try it.
I don't know.
Still
I've
like
got a
to-
gut that it's going to be a problem. So, okay. Let me know if you try that out. I'd be very interested in the results.
Yeah, I'll let you know. Can you hear the music?
Negative.
Oh, it's just in mine. Oh, that sucks for you guys. Good. All right. I will share that though. So,
Okay.
all right, guys. Well, take it easy. If you want to hang out